Welcome back. Let's do an inductor simplification. So the rules on inductor simplification are basically the same as resistors. So it's kind of a review of the same thing that we looked at already, but you know, it's good to do for a little bit. It's good to do once. We've got terminals A, B, and what we want to find is the equivalent resistance, or the equivalent inductance, you know, seen from AB. Okay, so the total circuit here, draw all of these guys in there. Some are in series, some are in parallel. $20 Henrys, 30 Henrys, 14 Henrys, 60 Henrys, 80 Henrys, 8, 15, 5, oops, I forgot one down here, 10 Henrys. Okay, that's the circuit. So once again, the rules are just the same as for a resistor, because the way to remember that is a resistor is a length of resistive, material, and so if you have two lengths of that, it's just a longer length. So you're just adding those, and inductors are similar. You've got a length of a certain of a coil of a certain length, and then another length of another coil, and you just put those together. You just have a longer coil, right? So you can add those. So we'll do a series of parallel and series simplifications. So this guy works out to be, well, to notate that, it's 30 in parallel with 12, which will be the product over the sum. That's our formula for simplification of parallel resistors and parallel inductors. Oops, not 12, 20. 30 in parallel with 20 is 12. This guy works out to 12. Then after you do that, you see you'll have a 12, like between, let's call this C and D. You can replace these two with a 12 ohm between the same C and D, and then basically between E, D, and C you have two in series. So it'd be a 12 in series with an 8, which is 20. And if you want to go one more step before you redraw it, which is starting to get a little dangerous, but we can do that. This 8 and 12 are in parallel with the 80, so you could write 80 in parallel with 20, and you end up with 16. And then you should for sure redraw at this point. Technically you could withdraw at every single transformation, and that's probably the safest thing to do in terms of just not making a mistake, but you can take some shortcuts. That's that, and then let's see, we got one of these. 14 was still there, right? Yeah. And then what I did was I replaced, all of these are between, this 16 is between C and E. So here's E, here's C. I could draw it anywhere between C and E, and let me draw it over here just to make it look nice, or I don't know, is this nicer? Anyway, you can draw it anywhere between C and E. All right, then some more simplifications. What we got, 14 is in series with a 16, right? So we can just add those guys and you get 30. Then the resulting 30 would be in parallel with the 60, right? The resulting 30 through here would be in parallel with the 60, and if you work that formula out, you'd get 20. So we could redraw at this point. And it shows up here. Okay, between E, let's call this F. All right, couple more simplifications. We've got a 20 in series with a 10, gives us 30. And then these two guys the 30 equivalent of these two guys would be in parallel with the 15 Henry. So 15 in parallel with 30 gives you 10. And redrawing it one more time, the 5 is still here. And let's call this G. So we simplified stuff between F and G. These three resistors between F and G, and we replaced them with a 10. Oh, this is really just B. I mean, you know, it's B, not G. So we simplified the stuff between B and F, and we ended up with a 10 ohm resistor between B and F. So I'll put him here. 10 Henry. Whoops, I was talking about resistors for a minute, wasn't I? Yeah, it's the same rules, but yeah, we're doing resistors. Anyway, so 5 plus 10 is 15. So the final equivalent is just a 15 Henry resistor. Okay, so it's the same thing as resistor simplification. It's just with like curlies instead of zigzags. All right, bye.